with this kind of a question, right? As with all questions, I mean, whatever question you will be asked, it's always going to go back to what we have at our disposal, you know, in terms of formulas and everything. So something like this, right? It says a square has each of its sides 1 unit and the midpoints of the sides are joined. So you have a square, right? This is like 1 unit, 1 unit, 1 unit, and then it has 1 unit. That's the red. Oh no, orange rather. Is it orange or red, this one? Or red? This is 1 unit, right?
Yeah.
So they then say that the midpoints are joined, as we can see here. This midpoint is joining that midpoint, joining that midpoint, joining that midpoint. So here we can see we have to be creative, and it's clearly not straightforward. Now, in terms of us being creative, let's see what we're seeing here. It says, determine the length of each side of the new square. So you see here, they're saying the length of each side of the new square. So we can see here in our image, we have 2 more squares. The first one is this one. So we have to find its length, like the length of each side. And then after getting the length of that one, we have to move on to the third one and get those lengths.
Yeah.
Yeah. So looking at this, right? I mean, starting with the green one. I mean, if you look at the green one, we can see that if the length here is like 1 full, 1 full, 1 full, 1 full, what can we do to get the green length here?
I was thinking because it's the midpoint where the corners meet, can't you say the one side's half and the other side's a half?
Definitely, we can definitely do that. You see, it's even easier for us to do it like that. This is a half, this is a half, this is also a half.
Mm.
All the sides here are a half. So let me not write too much unnecessarily. So all the sides here are a half. So what can we do to get the green length there?
Working with a triangle now.
And they say this is a square.
90 degrees. Can't you do Pythagoras?
Yep, we definitely can, because this part is the hypotenuse side, you see. So we know that the hypotenuse side, you can label it whatever you want, really. So let's just maybe say r squared is equal to a half squared plus a half squared. And then this is going to be equal to a quarter plus a quarter, right?
Yeah.
This is going to give you 2 quarters, which is going to give you a half. And then from there, you're going to square root both sides. And then r is 1 over square root of 2, which is giving us this length here. You can see it, right?
Yes, definitely.
Yep. So if all of these are like half square root of 2, it means that what is the length of this and this?
You add it. So 1 over square root 2 plus 1 over square root 2.
Well, remember the whole thing is 1 over square root 2.
Oh yeah, so then half of it.
Yep. So you can already see, depending on what maybe your brain was thinking, right? It's normal to maybe even think like that in an exam. But then you always want to ask yourself, but then why would it be doubling? You see, because the whole thing is what's 1 over square root of 2.
Yeah.
So half of that is what goes there on the green side. So here we know half of 1 over square root of 2 This is giving us 1 over 2 square root of 2. You see it?
Yeah.
Yeah. So those are the dimensions that we put on our image here, right? So it's like 1, 2 square root of 2, 1, 2 square root of 2. So now
Why
we
do you,
can,
sorry, why do you times it with a half?
because that's what off means. You see, half of 1 over square root of 2. Because we want half of it, right?
Yeah.
And then off means times.
Okay.
Yeah. That's how we got what we got here. Because remember, whatever you say in words, you can just translate it into math if you need to work out something, and then you will be good to go. You see, as long as you can translate it into math, then you'll have a good time. So with everything that we have seen here, we're already getting the dimensions of this side here also. You see,
Yeah.
and now we're dealing with, we need to get the blue length here, and you see here, this is also a triangle we can use.
Yeah. So then you do the same thing. Pythagoras.
Yep, it's definitely gonna be Pythagoras, because remember, this is a half and a half. You see, a half and a half means that this is 45 and this is 45, you see, meaning that this is also 45 and this is also 45. So if this is 45 and this is 45, it means that this is 90, because angles on a straight line need to add up to 180, you see. So that's why this is also 90 over there. So now your Pythagoras again, I mean, like you can already see, we're not doing anything crazy or fishy. We're just gonna have there, we can think whatever letter you want there. Let's maybe say x squared is equal to this number squared plus that number also squared. Let's see there. And then this here, you're gonna have 1 over, at the bottom, we have to be careful. We can just put it in the calculator. 2 square root of 2 squared is gonna give us 8, if I'm not mistaken. Yeah.
1/8. Yeah.
2. And this is 2 over 8. Of which this is still just x squared. And then this is just gonna give us 1 over 4. And then we can then just, you know, put a square root here, put a square root there.
Yeah.
And then x is a half. So I see that's quite interesting. But it is what we're getting, you know, so we don't have to like stress too much about it. Because this has to be longer than each of these, you see.
Yeah.
So this is just a half. So that is that. So that settles question number A, right?
Yeah.
The one that says the length of each of the new squares. So the other thing is with questions like these, right? Don't just think that the lengths are random, because even if you look at the next question, we should get here the area of the new square. So meaning each square we should get its area. So whatever we have just done now, we're gonna do the same for areas, you see. So if you look at B, let me see what B looks like here. Let's do B. B. So we're dealing with areas now. So remember, area of any square is just length times breadth. So for the red one, we can start there, the area of the new square. Yeah, so I'm like with the original square, let's write here original area is just 1 times 1, which is 1. So the first new one, we have put it in, we put that image in green, right? So let's say here first new. The area, you already know it's going to be the length here, which is the full length. Remember, it's 1 over square root of 2. Remember?
Yes.
Yeah, so it's going to be 1 square root of 2 over 1 square root of 2. Oh, 1 over square root of 2 rather. So it's 1 over square root of 2 times 1 over square root of 2 This is 1 over 2. And then the next one, which is in blue, you're gonna put the a half times a half.
Yeah. 1 over 4.
Yep, it's gonna be a half times a half. Just go to 1 over 4. So you can see here, if we look nicely, right, at these lengths that we were getting, there are, we can almost assume, not assume, but I mean, like logically speaking, they're gonna form some kind of a sequence. But let's see what this third question is asking. It says we should get the sum of the areas. We should determine the sum of the areas of all the squares if continued indefinitely. So the word indefinitely here, what does it remind you of?
Infinity.
Yes, sum to infinity, especially when they use the word sum here. You see, we should think of sum to infinity. So I think for what you have on Wednesday, this question fits a good description because it's not very straightforward. You see, but we can see that, you know what, it's not like crazy.
Yeah.
Which is what we should keep in mind for other questions. They may not be clear, but they won't be like crazy to the point where it's just like, you know, random madness. You get?
Yeah, no, I get it.
Cool.
I think the trick is the way they ask it is like a word sum.
Yeah,
So
it's definitely like a word sum.
Yeah, so it makes it confusing. But then I just try to break it up as much as I can.
Yeah. So the words, you can always just look for words that may mean something that your formulas can help you with. So here now, the areas, the first thing is you want to see them as a sequence, you see. So if you look at the areas here, 1, a half, a quarter. So the sum to infinity needs the first term in R, right?
Yeah.
Of which A here is just a 1. R looks like it's just a half because R is going to be a half divided by 1 or a quarter divided by a half, you see, which is just in your calculator, it's going to give you a half. Yeah, you see it, right?
Yeah.
So meaning the sum to infinity here is 1 over 1 minus a half, which is just 1 divided by a half.
And that gives you a 2.
And then you have your answer, as you say, a 2.
Okay, that was simple.
Yeah, not bad at all. Not bad at all. So with what we have realized, this next question here, right, says we should get D, which is the sum of all the perimeters of all the squares if continued indefinitely. Let's read that again. The sum of all the perimeters of all the squares if continued indefinitely. So again, the word indefinitely is giving us, again, sum to infinity.
But then also all the perimeters. So doesn't that mean you have to add?
Yeah, it's going to be now a different sequence. It's going to be a sequence of the perimeters. You see here it's a sequence of the perimeters. The previous question, it was a sequence of the areas. You see, so us here, if you look at our image, right, we just have to get a sequence of the perimeters. You see, starting with the first one, the red shape, you can see it, it's like 1 plus 1 plus 1 plus 1. You see, that's the perimeter.
Yeah, so it's 4.
Yeah. So for D, we can start with perimeter of 4. That's the first term. The second one is going to be 1 square root of 2, 1 over square root of 2, and then that's 4 times. You see, so
Yeah.
that it's just going to be 4 over square root of 2. The third one, it's like a half times 4, right? Which is just going to be 4 over 2. If you want to write it as 4 over 2, you can, or we can easily just write it as 2.
Lever,
Yep.
how do you get the 4 over 2?
Because
Because
you see,
if
it's
you put
a,
it in the calculator, you get something else. Completely different.
well, remember, this is just saying a half plus a half plus a half plus a half. So it's a half times 4. Because it's 4
Okay.
sides, because it's 4 sides that are each a half. So 4 sides that are each a half is going to give us 4 over 2. Oh, did I say 4 over 4? I meant 4 over 2, sorry. And then this is a 2.
I mean, not that one, the one next to that one. Sorry, the 4 over square root.
Square root of 2. Oh yeah, it's the same idea. Because you have 1 over square root of 2 as the length of each side, right? You see here, each side here, we said it's 1 over square root of 2. We just know that we have 4 sides that are like that. So that's the same idea. 1 over square root of 2, we're going to multiply it by 4 because there's 4 sides that are each 1 over square root of 2. In the calculator, it's going to give you something that has been rationalized. Meaning in the calculator, when it sees something down here with the square root, it's going to automatically multiply the whole thing with that value over itself, which is going to give you 4 square root of 2 over 2.
Okay.
You got that right in the calculator, or even it will just give you 2 square root of 2.
Yeah, they got that one. The 2
Yeah, square root of 2. Yeah. So we see that's how they got the 2 square root of 2 there. So you can either write it like this, or you can write it as the 2 square root of 2. It is totally up to you.
So it doesn't make a difference.
Yeah, it doesn't make a difference. It's just what the calculator will show you. It will show you something that has been rationalized.
No, that's fine. I'm just checking because I'm scared if I do that and then it's not right, then.
Yeah, so yeah, your calculator will always help you. You can always just use your calculator, you know, because it will also usually give you something simpler to work with. So with everything we've written down, the fortunate thing is that we have, what do we have? We have, what do we have? We have a sequence now.
Yes.
Now this sequence, we have to determine what kind of a sequence it is. Is it geometric, arithmetic? But because anything with sum to infinity is always geometric, we don't have to guess. We already know it's geometric. So meaning we need A here and R. So A is equal to 4. And then R is equal to this divided by that.
Which is square root 2 over 2.
2 divided by this. You mean 1 over square root 2? Oh, no, is it? Yeah. Wait, what? No. What is 2? Because it's like the R is 2 divided by this, or this divided by this, right?
Let me try it in fraction form. Yeah. Oh.
Yeah, what are these answers?
I get a square root 2 over 2.
Yeah, so these are equal to each other.
Yeah.
Because remember, this one, they will have just rationalized it, meaning your calculator would have just multiplied it by square root of 2 over 2. I mean, square root of 2 over square root of 2. Meaning at the top, you'd end up with like square root of 2. At the bottom, you'd end up with the 2. You see? So that's why they are equal to each other. So again, I think it's all like, if you can use your calculator, then you'll always be getting the same answer so that you can be calm. So let's see here. Square root of 2 over 2. Square root of 2 over 2. And then R is equal to square root of 2 over 2. So now we have A and R, right? So our sum to infinity is just A 1 minus r. So meaning this is like 4, 1 minus square root of 2 over 2. And then we can just put all this in the calculator, right?
Yes. That I get as 8 plus 4 square root 2.
Perfect. And then that's our sum to infinity.
Okay. Makes sense.
Fantastic. Anyways, so that's for this very good question. You can see this one was not common, but it was sequences and series.
Yeah.
And for Wednesday, I mean, we can already see that the pictures we get, we can just do what we can.
Definitely.
Perfect. Yeah. So we should move on to the next picture.